Okay, so welcome to Unit 1, Day 1. If you notice, there's already something written down because I started and the video crashed. So one of the fun things we have to deal with now. Luckily, I wasn't too far into the video. So Unit 1, Day 1, solving systems using graphing. You probably remember doing this in Algebra 1, hopefully. At least it'll ring a bell once we get started. So our learning target is I can solve a system of equations by graphing. And I can classify systems as independent, dependent, or inconsistent. So those are three vocab words we're going to, once we get started here, we're going to explain what those three mean. So the first thing is a system of equations is a set of two or more equations. And basically that just means that here's two equations, that's a system because this x and that x are the same number. They represent the same thing. The y's represent, both y's represent the same number. So on this guy, is 1, 1 a solution? Well, the easiest way to figure that out is to plug it in. So if you want to pause here, you can plug in 1 for the x's and plug in 1 for the y's. See if the top equals 19 and the bottom equals 2. So here I plug this in. So 2 times 1 is 2. 17 times 1 is 17. 2 plus 17 is 19. Okay? And then on bottom, 3 times 1 is 3. And then plus negative 1 would equal 2, so that one is a yes. That one is a yes. Now, let's plug in this guy here. So take a moment, pause the video, and plug that in. Okay, so now when I plug in 2 and negative 1 for x and y, notice the top equation here, 4 plus negative 17 does not equal 19. So right off the bat, that one's not true. I don't even need to check the second one. There's no way that this is a solution to the system because it doesn't make them both true. Okay, so the idea of a solution is it makes, when you plug it into the equations, it makes them both true. Now, if they are, like these are both linear equations, our options here are we can have one solution, we could have no solutions, and we could actually have infinitely many solutions. So this is one of those that has just one solution. Okay, now if we want to solve by graphing, we need to remember how to graph. So this guy, these are in slope-intercept form, which is perfect for us. And if you remember, that's the y-intercept, and the number in front of x is a slope. Now, to be able to fit this on here, if I count this up, the y-intercept 7, if I go 1, 2, 3, 4, 5, 6, 7, that's off the graph. Sometimes that's not so nice. And you can do it if you want, but we could also make this like worth 2, 4, 6, 8. We'll make each line worth 2. And that way it fits on the graph. So I'm going to go up 7. That means I'll be halfway between 6 and 8. And then the slope of negative 2 means down to the right. So I'm going to go down 2, and then we can make this 2, 4, 6, 8. We can do that too. So down 2 over 1 would be somewhere in here. Down 2 over 1, somewhere in there. You kind of see that pattern. And you can connect the dots here. Just draw some straight lines here. And then the other guy, this crosses at negative 2, so that'd be down here, and that's negative 2, negative 4. And it goes up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. And if you see right there is where they cross, which the way we scaled it's not so easy to see, but the x value there is 3. The y value looks like 1. And for these graphs, we're going to give you ones that have nice, neat answers. We're not going to give you decimal, answers that have decimal answers in here. Okay. Now this guy here, this is standard form. Okay, so we need to get the y by itself if we want to graph. Or the other option, that's not going to work so well, so we're not going to do that. If you remember, there was a way to do standard form where you could cover up the y, cover up the x, and maybe when we get to one that's easier to do, we'll do that. This one doesn't work so nice. So what I'm going to do is put both of these into slope-intercept form. So that's what I have here. I just move the x's to the other side and have y by itself. Now, to graph this guy, here's my y-intercept. And I can do whole value. So 1, 2, 3, 4, 5. Has a slope of negative 2. So that's down to right 1, down to right 1. And you can just follow that pattern. This other guy, y-intercept of 2. Slope is 1, so up 1, right 1, and boom, we already intersected the other line. Okay, if you've got a straight edge, that's great. Doesn't have to be perfectly straight, but you can see this value right here. That's right 1, up 3. Okay, Now, for the sake of time, I'm gonna skip number 3. If you want to try it yourself, right there's the solution. It's -3, -2 is the answer if you want to try it yourself and just see if you know what you're doing. Number 4 is a little bit different. These are the guys that sometimes the graphing part's difficult. Keep in mind here that when it's a y equals, that's a horizontal line, and when it's an x equals, it's a vertical line. Okay, so this guy, y equals, that's a y-intercept of 5, but it has no x's. So this is basically the same thing as 0x plus 5. So the slope is 0. The slope says go up 0 or down 0 and keep running. So that's going to make a flat line right here. And if you notice all of these points, if I plot all of these points, they all have a y-coordinate of 5. So like this is 0, 5. This is 1, 5. This is 2, 5, 3, 5. On all of those, y equals 5. The x didn't really matter. This one here, the x always has to equal -2. So we're going to go -2, put a point. Notice that's -2, 0. Here's -2, 1, -2, 2. Okay, so x is always -2. So it's going to be a vertical line going straight up and down. So where do they meet? What value makes both of those true? Well, it's when x is -2 and y is 5. Something I didn't really mention above here, as we're getting these answers, one way to check yourself, if this is a test or a quiz and you want to make sure you're right, plug it in. Plug 3 in for x, plug 1 in, for y. So -2 times 3 is -6, plus 7 is 1, and that's what it's supposed to equal. Here I've got 3 minus 2 equals 1, which is what it's supposed to equal. So you could pretty quickly check yourself and make sure you're right. Okay. At the bottom here, this first one is fine. The second one, I need to get y by itself. So I'm going to bring that 2x to the right side. Okay. So I need to graph these two guys. So the first one has a y-intercept of 3 and a slope of 2. So that means up to right 1. I can also go down to left 1. Because notice I still got a positive slope going to the right. And then this guy here crosses at 1. And it has a slope of 2. So up to right 1, up to right 1, down to right 1, down to right 1. If you notice between these two guys, they never cross. It's like the second line can't quite catch up to the first line. It never catches up. And all that means is there is no point that they share. Okay, so this one is no solution. Okay, no solution on that one. There's no answer that makes them true. Okay, so what that means is when we say no solution, we're going to get to the back, we're going to fill this in on the back. This is not consistent. It doesn't have an answer, so we call that inconsistent. Okay, now up here, these all had one solution. So, we said in our, up here it says independent, dependent, inconsistent. Inconsistent means there's no solution. Now here we have one answer, so it's kind of all by itself is the way I think of it. I don't know how they came up with the name for these, but it's all by itself, so it's independent. So these guys are all independent because they have one answer. So you probably figured out the third case, there's one solution, there's no solution, and then the ones that have everything in common are going to be dependent. Because, which answer you're talking about, well, it depends. They have a lot of answers. So let's take a graph this guy and see what it looks like. So first off, I'm going to take that second guy and I'm going to get y by itself. So I brought the 4x to the other side. And then now I'm going to divide by 2 to get y by itself. And when I did that, I got the exact same equation as above. I divided everything by 2. So I got 2x plus 3 and 2x plus 3. Well, if I go graph these guys, so here's plus 3 as a y-intercept. From there, go up to right 1, down to left 1. And I go graph this guy. It's going to be the exact same points. So these two lines are actually, they coincide. They're the exact same points. So everything that's a solution to this one is a solution to that one. So if I ask you for what's the answer, you'd say, well, it depends. Which one do you want? There's infinitely many of them. Okay, so on this one, there's infinitely many. Infinitely many solutions, we call that dependent. Okay, that's dependent. So let's flip this over now. We got our notes on the back we're going to do. Okay, so what does it mean for a system to be independent? Again, I think independent, out on your own, there's one solution. What does it mean for a system to be dependent? And the way I think of that is, well, it depends. If I said, which answer do you want? You say, well, it depends. There's a lot of them, so there's infinitely many. And then what's it mean to be inconsistent? If something's inconsistent, it doesn't work, there's no solution. Okay, so how can you tell? Well, if you remember from Algebra 1, if there's one solution, it's almost like things work nice. You know, I put that in quotes, everything works nice. When there's infinitely many solutions or no solutions, while you're solving it, the y is wiped out. Okay, so like when you're trying to solve for x or y, the variable is wiped out. The y's and the x's at the same time were gone. When you got rid of the x's, you also got rid of the y's with them. Okay, so if I look at this guy, and then when it was no solution, the same thing happened, but the result was not a true statement. Let me show what I mean by that. So when I look at this guy, and this is kind of reviewing some solving by elimination, but if I want to get rid of the x's, I need to make this the same as that. So if I took everything times 5 here, okay, so I try to get the proportions the same. So 5 times 3x would be 15x. 5 times y would be 5y. 5 times 5 would be 25. And notice if I go to subtract straight down here, if I try to subtract straight down, 15x minus 15x is 0. 5y minus 5y, because we're subtracting all of these, I should put in parentheses, so 5y minus 5y is 0. 2 minus 25 is negative 23. Now notice the x and the y's are gone. And how that happened was they were proportional. You know, because if I took 3 times 5, I got 15. If I took y times 5, I got 5. Those proportions are the same, but 5 times 5 is not 2. Okay, so that's not true. So the y's would cancel out like this. Okay, but this is not a true statement. 0 doesn't equal negative 23. That's not consistent, so there's no solution to that one. Oh, I'm sorry, we want to say inconsistent. Yeah, I spelled it wrong, but inconsistent. The next one, again, line the x and y's and z's up here. So I want the y's, let's see, that'd be 2y. If I bring the x to the other side, it'd be 4x, and there'd be 6. So look at the y's, look at the x's, and look at the constant. What do you see in common there? Double it, double it, double it. Over here, multiply by 5, multiply by 5. Nope, don't multiply by 5. That doesn't work. That's inconsistent. But here, if I double it, double it, double it, they're really the same equation. If I took all of this times 2, it's just going to be that equation, which means it's the same thing, which means it's dependent. Okay? It's important to line the x, y's, and z's up. So if I got x, y, and constant, let's get the x to negative 2x plus y, negative 3. Okay, so if I take it times negative 2, take it times negative 2, nope, they're not the same ratio. So now it's not a matter of either one of these. This just means if I went to solve it, I would get one solution, which means it's independent. So if you were to eliminate the x's, the y's would still be there. Or eliminate y's, the x would still be there. Over here, the x and y's went out together. Okay. Now, these questions, don't make them harder than they are right now. This very early, we're just going to give you a picture and say, what are the solutions? Okay, so solve a system. Now, I'm not even looking for a coordinate necessarily. Like on this one, that's not on a perfect corner. So I would just say the solution is right there and there. Okay, and that would be good enough on a test for me, or a quiz. It's just those 2 points. Now here I can see where it's at. It's where these 2 lines cross. Okay, so it'd be negative 1, 0, and this would be at 4, 5. Okay, so it's there and there. I got this parabola and I got a linear equation. They meet at 2 spots, so they have 2 solutions.